Symposium. It's our pleasure to once again this year be able to co-sponsor this symposium on visualization and transportation. And I think it's a testament to our commitment and the importance we place on the topic that in the, call it uncertain environment that exists in Washington, D.C. right now, we're still able to provide support and have some people come out and participate. I feel very fortunate this morning that I don't have to spend 30 seconds convincing you to listen to everything else that I have to say. But I would like to note that when I was trying to pull together what I would consider to be a keynote talk, it was very difficult to try to boil down the slides to a set that I thought were appropriate. And it was eye-opening to me just to understand and see the breadth of the activities that we have going on even within Federal Highway Administration. And so it makes it a challenge to try to talk about all of it, but it's very exciting in the sense that we have a lot of things that are happening. So just a quick outline. It looks short, but there's actually a lot to it. I want to talk briefly about some challenges and opportunities around visualization. Then I'll spend a fair amount of time, the bulk of the presentation is talking about our activities with visualization and FHWA. And then I'll talk about some of our, call them key initiatives, but things that are sort of important to the administration and the agency and where we have some visualization activities going on that maybe get a little bit more press than some of the others. So first, highway industry challenges. This is broadly across the highway industry. We're being asked to accelerate project delivery. It takes an awful long time to put a project into place, and we're being asked to shorten up those delivery timelines. At the same time, reduce costs, and you know that's a challenge to do both of those. We're really trying to focus on the entire life cycle, and there are visualization challenges and opportunities in each one of those phases of the life cycle, starting with planning, real estate, right-of-way, environment and permitting, design and construction, operation and maintenance, and ultimately even maybe disposal of parts of our highway system. We also have a lot of visualization activities in our research and technology development transition programs, which aren't directly a part of the project delivery process within the agency, but certainly facilitate that as we transition technologies into the mainstream. And then lastly, we see a challenge in the vast quantities of data that are coming our way now. And Pat mentioned this a little bit. And you know, whether that's data that's coming off the road network with the technology that's going into vehicles these days, and we're talking about connecting those vehicles to the infrastructure, we're just going to see an exponential increase in the amount of data that we have to sort through. And so that's a real challenge as well. Specifically to data, I just mentioned large and increasing quantities, and that seems to be ever increasing. We have some problems with standardization of data, and the more we get, the harder that becomes, and the harder it is to work around non-standard data. And so we really want to spend some time trying to get in front of some standardization activities, and that's not necessarily our role within Federal Highway Administration, but we want to advocate the importance of doing that to the industry writ large. Also, you know, I think automation is a challenge as we get more and more data and larger volumes of data. Just trying to automate the collection of that data is beneficial and a challenge, and looking for automated ways to analyze that data also is beneficial. Another challenge is that with a lot of these data sets, we're collecting some very robust information about the highway network. It has multiple uses, and so in a typical state Department of Transportation, you know, we may have some folks that are looking at asset management, and they work in one part of the organization. The operations and traffic folks work in a different part, but they have needs for the same data set. The safety folks work in a different part of the organization and have needs for the same data set. So who owns that? Who's responsible for maintaining and managing that data? And sometimes, you know, there's a lot of this going on. But we need to figure that out. And then lastly, there's some privacy issues, and that's really focused on data collected from vehicles, where we may be able to sort of track a person's travel habits and things, and we have to be able to anonymize that if we're going to be able to put it to good use. So opportunities. In the program or project delivery arena, there's there's an incredible opportunity to modernize the highway life cycle. And as I said, it starts all the way at planning and goes all the way through the operations and maintenance and perhaps disposal. Public engagement is another key area where we see visualization having a big impact. System performance, that could be traffic data and simulation, congestion management. It could be connected vehicles. We were talking about connected vehicles that communicate with each other, connected vehicles that communicate with the infrastructure, and perhaps even with the traveler, where you may have heard the term V2P used recently, which is vehicle to person, where we're going to start passing this data around. And all of these things provide tremendous opportunities for improving the performance of the system as a whole. But as I said, they're sort of, with them comes some challenges. System level analysis and decision support at a very high level, when we want to take a look at the entire network and how it's operating and performing, and how we make decisions, whether that's about operational strategies, whether that's about investment in new technologies or trying different ways of doing business. Visualization provides an opportunity to really look at that high-level systems analysis. And certainly in the area of asset management, and we've seen a lot of activity there with respect to geospatial data and being able to more effectively manage the information we have about the condition and performance and deterioration of the highway network. Continuing in the area of technology development, there's some clear applications of visualization and research and knowledge discovery, looking through large data sets, whether they be experimental or those that result from modeling and simulation, synthetic data sets, if you will. Visualization tools and visual analytics provide a great opportunity to discover knowledge amongst the data. Just data analysis, even once we've sort of formulated some hypotheses and are trying to study those and analyze data that we might be getting from pilot or demonstration projects. Again, some very good opportunities. Technology demonstration, evaluation, and transition. And this is one area where we have seen some success in utilizing visualization techniques to go out and convince other folks that, yes, this does work. It's very powerful. And that relates to training as well. Once we get to the point where we're transitioning a technology either into practice or to the next phase of development, visualization provides a very robust way to disseminate that knowledge and move that technology development forward. So, what's our vision as an agency? What we really are hoping to achieve is an integrated process where we can maximize the use of digital data throughout that life cycle and effectively deliver a federal aid highway program. And again, that's from cradle to grave. We see digital data being the way to go. We see to the extent that we can maximize the sharing of that data or the commonality of that data set all the way through the life cycle, we get more effective results, we're more efficient, and we have a lot less mistakes and redundancy that takes place. Specific to data visualization, again, I mentioned research and technology development. We certainly see there a role for visualization there. System performance, decision aids, again, whether that's investment or system operations, doesn't really matter. It's still effective in decision support. And this is really aligned with AASHTO and the industry. And we've spent a fair amount of time talking with AASHTO and industry organizations to make sure that we're all on the same page as we move forward. Because we can't do this alone. That's clear. And I don't believe that AASHTO or the state DOTs can do it alone. And I don't believe that the industry can do it alone. So this is a graphic. I know it's kind of busy, but it sort of depicts how we look at the life cycle now. We start out with planning, we scope, we get environmental approvals, we acquire the right-of-way, we design, construct, inspect, then we operate and maintain, and then we have sort of a collection of programs, safety and asset management things up in the 10 to 11 o'clock range of this wheel. And the idea is that we have processes and data systems in the middle of the circle that support each one of those phases, but there's not much connectivity across those. And so we get to the point where we may do a very robust design, but we don't typically pass that off to construction yet. And so there are these points where we sort of toss something over the wall, and it's not very efficient, and that's what we want to try to change. So what we want to do is, and this is sort of an example of trying to grow that, but we want to have this space in the center of the circle where we start to use that same data. So we start out with a GIS model, maybe in the planning phase, to look at corridors or alignments. We put together a systems model so that we can help go get our environmental approval And then, right through virtual design and construction where we have the designers handing off a model that's stamped digitally to the construction folks who are using the exact same data to go build it with automated machine guidance. Our QA/QC folks who are doing inspections are looking at the exact same model. That gets passed to the folks who are going to operate and maintain the system as well. So everybody's working from a common data set. And over time, we hope that confluence of common data in the center will continue to grow as we move forward. And again, just as an example, we have some good tools in some of these areas now, but what we want to do is try to connect those and to integrate all of these together in a working life cycle approach. So I'll move into visualization efforts that are ongoing at the agency. And as I said, there's quite a list of these. I'm going to try to just hit some high points. But if you have any questions, there's about 8 of us from the agency that are here this week. And we'd be happy to try to answer questions at any time. So this loosely goes through sort of that project delivery life cycle. So starting with planning, we have a website that the Office of Planning, Environment, and Realty maintains on visualization for transportation planning. And this is the URL is there. It's been around for a while, and it's really based on scenario planning and how we utilize visualization in the planning construct. Just an example of some more opportunities. This performance-based planning and programming guidebook just came out in September, and these are the items that are included in that guidebook: recommendations for visualization, developing goals and objectives, selecting performance measures, identifying trends and targets for your performance measures, identify strategies and analyze alternatives, develop investment priorities, and linking planning and programming. And aside from the recommendations for visualizations, the ones with the asterisks we really see as high value added if we can start to utilize some visualization techniques, with respect to putting this performance-based planning and programming into play. Another planning example, we're starting to do a lot of work in mega region planning. And so what we're doing is we're looking at larger planning areas. They're more complex because they cover a larger geographic area. They're more complex because they cover a variety of conditions within that geographic area. And so we're increasingly using visualization techniques in these mega region planning seminars. Moving to design visualization, so this is really at the beginning of the design phase. Again, we have a website that's maintained by Rich McDaniel and our Eastern Federal Lands Highway Division on design visualization. It's a very good resource. It's one of the most visited pages in all of FHWA. And there's a wealth of information there, a URL at the bottom, and we can give this information to you later as well if you don't get it. And this is just an example of where they're headed. They're fully integrating 3D design capabilities now within the Federal Lands Highway Divisions. And in a very detailed way, not just looking at sort of early project approval visualization where they want to see what a bridge is going to look like in the national park, but all the way down to replacing girders and things on the bottom of the bridge. And that's all integrated into one model, so it's not a separate snapshot or raster image that looks nice for your public engagement, but it's an integrated model with all of those dimensions included. They're developing specifications for these models. They've selected a couple of them, I think 3 demonstration projects. They're doing some training for their designers to start to work in 3D. And they're going to be evaluating these pilot projects and trying to look at some return on investment. Moving to the safety arena, we're utilizing 3D visualization for road safety audits. These are sort of a formal safety performance review. A team of folks sits down and looks at an existing roadway design. It could be proposed changes. It could be a proposed new roadway. It can happen at any time in the project life cycle. But the idea is that they sit down and they look at sort of the safety implications of that design and suggest improvements or changes. And in a lot of cases, you can imagine that the more complex the design is, the harder it is to understand that from looking at plan sheets and 2-dimensional drawings. And so the 3-dimensional models enable them to sort of understand the safety implications of that design by being able to visualize it in 3 dimensions. These are sort of examples where this is advantageous. Large complex projects lot of grade change, innovative or unusual designs that folks aren't as familiar with, inaccessible locations where it's hard to go visit the project site, or where you're going to have a lot of public involvement and you want to be able to demonstrate that to the public in an easy way. Recognize that to do a 3D visualization for a road safety audit does sort of increase the amount of effort that goes into it, so it's probably not a one-size-fits-all solution, but in a lot of these cases it does make sense, and we think that the extra effort is well worth it. In the Highway Policy Information area, this is a snapshot of the Policy Information Office. This is not a website devoted to visualization, but I wanted to show it because it's a place where we collect a lot of statistics about the highway network. You can see on the right-hand side that we have a map, so we're now displaying a lot of these state statistical abstract information in a geographically or geospatially referenced way, as opposed to in tabular form or other ways of doing that. So this is the front page of the highway policy information. There's a wealth of information there, and they're utilizing visualization techniques on the front of that website. Our policy office is also working on integrating some databases. This is an example of that, where we're looking at an integration platform in the middle of the slide. We have the National Bridge Inventory up in the right-hand corner, which is condition information and a lot of information about every bridge in the United States. Information is maintained in a very awkward and sort of 1960s design database. And if you don't know how to count columns, and if you don't still have a 22-inch wide dot matrix printer, it's kind of tough to sort through it. So we're working on ways to integrate that along with the highway performance management system down in the lower right, which is how we sort of keep track of the conditions and performance, and that relates back to how the federal highway program money is allocated. The RADS in the lower left is the Recovery Act data system. We're trying to integrate that in as well. And then up in the upper left is VIS, which is where we sort of keep track of all the apportionments, obligations, and the funding side of federal highway projects. So they're working real hard on, again, trying to integrate this to make it more effective. You gain some efficiency by having these integrated seamlessly as well. Again, in the highway policy area, we had a GIS initiative for that HPMS that I mentioned on the last slide. This is just an example of data. This is AABT, and it's displayed in a graphical way, again, geospatially referenced, and this is available for anywhere in the United States where they collect this data. And there's no client or tool needed on your desktop or on your system. This is all available on the web. Moving to the infrastructure area, we have a long-term pavement performance program. It's been around for about 25 years or so. We've been collecting performance information on I think it's about 2,500 pavement test sections around the country in a variety of climates, a variety of different design conditions, a variety of different traffic levels. And we've been collecting this data for a long time and serving that back out to the public. The InfoPave, the logo there in the bottom right corner is our public-facing website for accessing this information. And we're spending a lot more time trying to streamline that and make it easy for people to get to the data and understand it, rather than sort of data management and the structure of the incoming data at this point. We kind of have refined that pretty well, but we're really focused on how can we better serve primarily the research community who is looking at this data. As a complement to the long-term pavement performance program, we've started a long-term bridge performance program. It's been around for about 5 years. And in that 5 years, we've spent a fair amount of time trying to figure out how we should go about doing this. We can't collect information about the performance of all 600,000 bridges in the country, so we have to figure out how to cluster and distill that down to a representative set. Again, we're interested in different climate, we're interested in different traffic levels, we're interested in different types of construction. And so we spent a great deal of time doing some pilot projects to try to understand how we can collect a representative data set. It's still quite a massive undertaking, but we've had some success there. And the focus of this, again, is on long-term performance. How do we better understand deterioration and the condition of our bridges? And just, this is sort of a graphical representation of that data collection plan. You can see that there's That's big data. So in the late 1990s, we developed a digital highway measurement system that we fielded a prototype in about 10 years ago. We thought that the states would be dying to run out and purchase one of these so that they could collect real high-quality, high-resolution information about their highway networks. It didn't really work out that way, but through continuing to push on those efforts, that's been picked up by industry, and they actually were much better at commercializing and bringing that to market than we would have been. And so now, you can go out and buy this from, you can go buy the technology if you want from a vendor. You can go out and buy the service. Folks will come and collect the data for you, and that's what most of the states are now doing. So this is an example of technology development that we did that sort of turned into industrial suppliers, and the states are now really sort of, just in the last couple of years, there's been a huge increase in the number of states that are starting to think about how to use this data and collect it and maintain it. As I said, they're buying this data. The databases are huge. In some cases, it's overwhelming for the existing IT networks within the state DOT. Again, I go back to the concept that this data has applications across the DOT, and so trying to understand who's going to be responsible for it is a challenge. And different states are taking very different approaches to this, as you can imagine. But there's an awful lot of collaboration going on through AASHTO amongst the states to try to figure out the best way to do this. And it's kind of a long reference, but if you happen to go back and Google, is 3D imaging the state DOT's best friend? It was a really good article in the SparkPoint newsletter just maybe a month ago or so. And SparkPoint is a three-dimensional data collection conference. They run a series of conferences. It was used to be, maybe 3 or 4 years ago, it was based primarily on LiDAR and laser data collection. They're now doing a lot of photogrammetric work as well, where you don't need the laser, you just take stereo images and get very high-resolution data that way. But it's kind of an interesting article, and it talks about a fair number of states and how they're collecting the data, different approaches, and different approaches to how they're utilizing it as well. So, in the area of sort of the future or operations of the network, I mentioned connected vehicles, and we really see this as the future. The entire US DOT has a joint program office focused on intelligent transportation systems. There's 3 big areas or application areas for the connected vehicle program: safety, mobility, and environment. Again, the idea is that all of the vehicles talk to each other, all of the vehicles talk to the infrastructure, so that they can exchange information with things like traffic signal heads. They can get signal phase and timing. They can adjust the movement of the vehicles to accommodate the signal phase and timing. You get environmental benefits because you don't have people idling at red lights. You get operational benefits because you don't have stop and go. So a whole lot of possibilities here. And I'll just show an example of one. This is a snapshot of the mobility applications environment. We have a variety of data sources. We have infrastructure status, or data about the network that will go into the state environment. We have information coming from the vehicle bus. We have weather stations that may be providing information about weather conditions that may influence what they're going to tell the vehicles to do. Truck data, transit, buses, and GPS or some georeference location information. And then on the right-hand side of that picture is sort of just an example of some of the dynamic mobility applications. We can have intelligent network flow. We can have optimized traffic signal systems, not just optimized based on timing, but based on actual traffic conditions. We can have real-time changes to the network based on emergency response or needs, if we need closed lanes or things like that. We can do that. So a real promising future for a connected vehicle, but it's going to be huge amounts of data that are all going to have to be coordinated and provided to realize these applications. Another example in the connected vehicle arena, the safety pilot model deployment being done, and we have instrumented vehicles that have cameras, forward-facing cameras. We have some external sensors, radar, and we have vehicle-to-vehicle communications and some GPS and geolocation data. We're collecting continuous video on these, so we're getting drivers. The guess is about 18 million travel miles, over 1,000 driving hours, and it includes roadway data information so that can be correlated into the database as well. And it's going to be about 4 petabytes of data, which doesn't sound, if you're not an IT person, it doesn't sound too alarming, but that's 4 million 1 gigabyte USB sticks, and so that's an awful lot of data. This is just an example of some of the camera views that come in. There's a forward-looking camera, there's a camera on the dash and feet, there's a rear-looking camera, and one that's focused on the driver's face. We're keeping all of this information, so it's a large amount of data. We have privacy issues associated with it, folks, so if we're going to use this for research purposes, we have to be able to take that privacy information back out. And in terms of the data that we're getting off of the cameras, we're looking at ways to try to teach machines to automatically visualize the environment, if you will. And in one sense, this is almost like the reverse of visualization, because we're trying to get the machine to recognize something in a visual scene and pull data out of that. But it's really a lot of the same techniques, and the idea is that we don't have the resources to be able to go through all of this information with a human watching the video, so we have to figure out ways to automate the extraction and the features we need out of it. We also have a highway driving simulator that's at the research center in McLean. It was designed and built for driver behavior studies, but we discovered maybe 4 or 5 years ago that we could utilize it to look at highway design as well. And this example you may have seen before. I think we might have showed this 2 years ago at the symposium in Chicago. But it was an interchange in Missouri. In order to get the capacity, they were going to have to take the bridge down and put a wider bridge up. We showed through an alternative intersection design where the 2 roads actually cross to go across the overpass. That we could do it within the existing bridge, and so it saved money. It actually increased the throughput, reduced the accidents. We've been collecting data on this, and so it's a win-win. It's cheaper, it improved operations, and improved safety. But it's not intuitive for folks to cross over the left side of the road for a while. And so the designers came in and utilized our high fidelity simulator to be able to go in and look at the design in a synthetic environment and be able to make changes to that to actually do the design. And we were able to use a simulator for behavior studies to look at how people were going to view the data to help understand where we needed to put signage and what messages we needed to give them to make sure that they navigated this properly. And then finally we were able to use the simulator to look at modeling data to look at the benefits. Was it going to increase throughput and how was it going to affect traffic flow? So we discovered that the simulator had very good application here and in several different ways, and it wasn't really what the simulator was conceived for originally. We extended that to look at some ARTBA and a few other novel intersection designs, and that one that was built in Missouri heavily utilized our simulator. But now, because of those efforts, there's a lot of these being built in other states. There's been 17 built so far in a variety of states. There's plans to build 45 more in the ARTBA. We have 66 that are built and 61 that are in plans. Just as another example of how to utilize that simulator, we're also looking at active traffic management scenarios. We have a big project on cooperation with the Virginia Department of Transportation in the Northern Virginia area, where we're going to look at speed harmonization, and they're putting in a big active traffic management system where we can have dynamic speed limits, we can dynamically close lanes, we can have merges, we can do all sorts of things. And so the simulator was used to look at the signage and what's the appropriate signage for people to understand what's going on. And it gets all the way down to the nuts and bolts of the spectral qualities of the LEDs on that sign and how are they going to perform and things. So again, it's a great tool for doing design on things that are not sort of traditional or customary items. And this sort of there's a if we went a couple miles down the road, there's an accident where we actually started to close a lane off. I don't remember how long this. I'll let it run just a little bit, but this was all done just to support active traffic management concepts. there's just an example of different ways we can display that information. Okay, moving on to key initiatives. For those of you that were at the symposium in 2011, you probably remember that we formed a visualization working group within the agency. It's about 3 years old now. We have representatives from across the entire agency. We provide leadership and advocacy, or at least we try to, for visualization and innovative data analysis within the agency. We coordinate visualization efforts across the agency. Just based on what I showed you today, I think you can appreciate the breadth of things that are going on. And as Michael noted, with an expansion of what we're paying attention to, really from the virtual design and construction and the data analysis and a whole bunch of other areas, it's good to have a group that's talking to each other and coordinate all these efforts. We're also doing some collaboration. We have some initiatives that we've funded with some discretionary money to try to advance some visualization things. And we sort of serve as a focal point within FHWA for collaboration with the TRB community as well and other external partners. So real quickly, I'll go through. These were 4 initiatives that we funded about 3 years ago. They're all complete now, but I just wanted to show you a snapshot of each one. One was visualization of the National Household Travel Survey data, and that's data that's collected about people's travel habits. We have a visualization tool that can go in and extract different sets of information from it and draw maps and heat diagrams and things to make it much easier to understand that data. We also had a best practices in GIS-based asset management, where we work with a lot of the state DOTs to look at best practices and sort of pull some of these tools together. The third one was advancing strategic opportunities for data visualization, and this was really an attempt to look for holes or gaps in what we were paying attention to look for ripe opportunities that maybe we hadn't realized existed. And so we did some study about the business lines within the agency, looked at where visualization might be able to help, and got some good recommendations out of that. Piloting transformative visualization projects, paying attention to open data policies, which, and actually the administration is pushing that now from OPM and the White House. We're getting directives to enforce open data policies, so we're right on with that. And looking at how we can enhance our organizational capacity. We have to figure out how to sort of get these ideas into the mainstream offices rather than to have a cohort of people who are real passionate about it that continue to try to carry the burden for the entire agency. And last was a visualization tool for our federal lands highway divisions to look at their agency management system data for things like the National Park Service and where they could geospatially reference this and look at everything from safety data to design data to condition data, all in one website. Also want to mention Everyday Counts. This was an initiative that our administrator, Victor Mendez, stood up when he took office about in 2009. He really wanted to focus on shortening project delivery and accelerating technology deployment. He wanted to go out and work with the states to try to get some of these good technologies into practice. And so we spent a lot of time doing that. We selected a handful of initiatives, technologies, and from late 2010 through December of 2012, we worked with the states. We put on workshops. We organized a lot of webinars. We went out and shared data. We helped them get pilot projects started. And that was pretty successful. So we initiated a second round. We're calling it EDC2. And there's a couple of initiatives that were selected in the second round. And we talked about visualization in the first round, but we really didn't think there was anything mature enough to really push out to the states at that point. But our hope was that if the program continued, we could do that. And we were very fortunate in the second round. There was 2 things that were selected. One was the geospatial data collaboration. This is based on Utah's U-Plan model, where they're collecting a wealth of very accurate 3-dimensional information for asset management purposes. It provides a web-based data sharing and cloud-based tools so that you don't require any tools to be able to access and utilize the data. It's really, in some ways, it's an extension of our best practices initiative that I mentioned in the last couple of years. And the AASHTO Technology Implementation Group is collaborating with us, and I believe we have 14 states who have adopted something similar to the plan now and are taking this online cloud-based approach to sharing that geospatial data. The other initiative that was picked up in EDC2 is 3D engineered models for construction. purposes of EDC2, you could call that VDC, Civil Integrated Management, whatever term you like. But the point is that we do three-dimensional planning and design, and we translate that data into construction, so we can hand that directly to automated machine guidance systems to actually go out and build the bridge and the highway. I should back up a little bit. Prior to this EDC2 initiative that just got started in the last 12 months, we had an effort with AASHTO, with Associated General Contractors of America, with the American Road Transportation Builders Association, and Federal Highway Administration to look at civil integrated management, virtual design and construction. And there was a letter that was drafted out of their joint committee about 3 years ago to Federal Highway Administration asking for some help on this topic. And of course, we had already been talking about the fact that this was a good idea, and we wanted to figure out how to advance it. So we were working with them, trying to figure out how to share the data, looking at how we can develop models that can be utilized all the way through construction, and how we get DOTs, designers, and contractors all to collaborate. So a lot of the groundwork was laid under this effort with those three organizations that enable us to get the 3D engineered models selected as an EDC2 initiative. And just an example, under the implementation plans for EDC2, we set targets and we track states that are either employing the technology or innovation, as well as those who are considering it. And this is an example of where we have commitments from the states to look at 3D engineered models for construction. In the future, we're working towards a national website that is anticipated to go live in December. For the time being, you may recognize that URL is a design visualization website that our Federal Lands Highway Division hosts, and so we're collecting information there, but the idea is that we'll have a national website around the end of the calendar year. That was a request out of a lot of the initial workshops with the states that they wanted a clearinghouse for information as they move forward. We're also looking at a technical support services center, again, to answer specific questions from states, local public agencies, and industry, design and construction. There's been quite a handful of webinars and workshops. Some of those web-based webinars. Others are workshops where we have regional workshops where we'll find a particular state that's interested in hosting one on 3D engineered models. I know we've done one in Oregon, New York, Florida. I believe there may be one or two others. There's some work going on that New York State DOT is looking at putting together some tech briefs on steel bridge fabrication, and Iowa DOT is working on some implementation manuals that we hope to have available by midsummer next year. I have to mention MAP 21. We had a new authorizing legislation last summer, and there are specific references to advanced modeling technologies in MAP 21. Section 1304 on innovative project delivery methods specifically references digital three-dimensional modeling technologies as an innovative project delivery method. Doesn't prescribe anything, but it does recognize that. And I think it's good to see that in the legislative bodies of the Rural Capitol Hill, they understand this and are paying attention and support what we're trying to do. And then in Section 1503, project approval and oversight, the quote is there: the Secretary shall encourage the use of advanced modeling technologies during environmental planning, financial management, design, simulation, and construction processes and projects. And it does specifically identify 3D digital modeling. These are the goals listed. The legislation reads like a lot of legislation. You turn in circles and you try to make sense of the whole thing. But the goals listed there are accelerate and improve the environmental review process, increase public participation, enhance the detail of project designs, increase safety, accelerate construction, reduce costs. Sounds just like all of the objectives we already identified. So we're kind of excited to have acknowledgement of this from Congress. I want to mention an event that happened in May of this year, which we refer to as Data Palooza. This took place at US DOT headquarters. Michael Nesbitt from Federal Highway Administration was one of the leaders of putting this entire event together. And the purpose, correct me if I get something wrong here, but the purpose was really for us to be able to understand, to tools and technologies that may be available from the private sector or academia to help us with implementing performance-based programs and performance-based management, as well as for us to try to demonstrate our needs and to talk about the policy objectives and things that we had so that people could understand where we're headed with respect to performance-based programs that are prescribed by MAP 21. And we're going to have an event again next year. I think it's going to be in June next year, and in collaboration with another meeting in the Washington, D.C. area. So stay tuned for more on that. Just a quick snapshot. It's a whole list of folks who participated here. We had about 200 participants from DOT headquarters, 37 presenters, and about 23 exhibitors. So a very successful event for the first time around. We look forward to increasing the effectiveness of this in the coming years. I want to just mention quickly that we have about a half a dozen or so presentations this week. You'll hear 30 seconds on each of these in just a minute. So I won't say anything more about them. These are either authored by FHWA folks or supported in some way, either with technical support or assistance or financial support from FHWA. So, quick summary. As I mentioned, there are some challenges, but the companion to those challenges is that there's lots of opportunities. We feel like in Federal Highway Administration we've made lots of progress in several areas, particularly the VDC arena, and we're continuing to gain momentum, so it's a real exciting time to be playing in this space. I'm convinced and believe that this is going to require partnership and collaboration amongst all of us, federal, state, local governments, academia, and industry. If we don't all work together on this, it's going to be tough to implement because we all have a stake in the entire process. And as I said, the real benefit and the value to the highway transportation system comes when we integrate it across that life cycle. We can't do that if we're working pieces. With that, I'll close. Here's some contact information for me. Jim Boyer, who was on the steering committee for the conference, works in our office as well. And we have two folks who are leads in the visualization working group. Rich McDaniel is really our VDC, our design person on the working group. And Adele Santos, who works in our policy office, is really heading up the data visualization side and data analytics. So there's some contact information.